Suppose f of x comma y equals the constant 3, and the region R is a rectangular region shown here in the xy plane. We want to evaluate the double integral. So there are several things to notice here. Let's first define the rectangular region in terms of x and y. Notice how the interval for x is from -3 to +2. The interval for y is from -1 to +3, which gives us the rectangular region shown here. And again, this is our region of integration. Next, notice how our function f of x comma y equals 3 is obviously non-negative over this region, which means this double integral is equal to the volume below f of x comma y equals 3 and above the xy plane over this region. Let's look at this graphically. So in blue we have the graph of z equals 3, or f of x comma y equals 3. If we look down on the xy plane here, this shows the region of integration over the xy plane, and therefore the value of the double integral would be equal to the volume of the solid picture here, which we can see is a right rectangular prism. So we could evaluate the double integral using a volume formula where the volume is going to be equal to length times width times height. Therefore, we want the area of the base times the height. So we'll actually evaluate the double integral using a geometric formula and then also evaluate the double integral. Before we set up our double integral though, we know this is going to be equal to, again, the area of the base, which would be the area of our region of integration. This is a 5 by 4 rectangle, which would have an area of 20. So the area of the base would be 20 times the height of the rectangular prism would give us the volume. The height would be the function value of 3. So the double integral is going to be equal to 60, which means the volume of the solid would be 60 cubic units. But let's also evaluate this as a double integral. So we'd have the double integral. Notice how we're asked to integrate with respect to x first. The interval for x is the closed interval from -3 to +2. Again, we can see that here. With respect to y, we integrate from -1 to +3. Again, these are x values, and these are our y values. So we'll first integrate with respect to x. The antiderivative of 3 with respect to x would be 3x, which we now need to evaluate at 2, then -3, then find the difference. So we'd have the integral from -1 to 3 of 3 times 2 minus 3 times -3. So notice how this is going to be 6 minus -9, or 6 plus 9, which equals 15. So we have the integral from -1 to 3 of 15, integrated with respect to y. So we'd have 15y, which we now evaluate at 3, then -1, and then find the difference. So we have 15 times 3 minus 15 times -1. This is going to be 45 minus -15, or 45 plus 15, which equals 60. So notice how we did get the same value that we found using the geometric formula. And again, because our function is non-negative over this region, we could also include the units, because it is volume, of 60 cubic units. So we just evaluated this double integral two ways. We recognize that it did represent volume, which we could find using a geometric formula, and we also found the value by evaluating the double integral. In both cases, we found the volume of the solid here. I hope you found this helpful.